Hi, everyone, and welcome to this recording of Lecture 4 for MI 347. It is freezing out. It's also freezing in my house right now. Usually, I try to do a good sound system for this. There's a little buzzing in the background for everyone because I have my space heater pointed right at my body. It's like less than 50 degrees in my house right now. It's horrifying. But I didn't want to lose any time in class, so I'm recording this little lecture today, hopefully keeping it around 40 to 45 minutes in time because I won't be super distracted or go off tangents because there's no one for me to bug. It's just me alone in my lab working on stuff here. So real quick on today's content, everyone's supposed to post their animation review stuff that we had from last week. I'll be looking through all of that in our animation section and kind of giving everybody a little bit of feedback and a few notes, as well as on the lab stuff, which we'll talk about at the end of the lab here. Today, we're going to get into how motion is interpreted. We talked last week about staging, sort of placement and posing, and now we're really thinking about the curves, the graph editor, how our characters transition between those poses. The first thing I want to talk about is this concept of slow in and slow out. I like this example of the drifting car because we can see the way it's steering in, and the transference of inertia is what we're demonstrating. The poses can be exactly the same, but the way we get to those poses is what really tells us the story of the weight, the inertia, and the speed that's happening here. So you get to this stage, and we're going to be doing for project one, lifting up a heavy kind of an object, and you'll have all your poses knocked in. You've done everything in pose to pose, and you sort of get to this spot where you ask yourself, okay, like now what do I do? All our poses are put in, and where do we go from here? What we get into is the laws of motion. I have this little video. The slides are all up, and I'd like everyone to check it out. But it sort of just describes Newton's laws of motion. And the three laws of motion are, of course, an object motion tends to stay in motion unless interacted on by another object. There's that idea of force equals mass times acceleration, and that like every force has an equal and opposite reaction. And these principles are really essential to understanding exactly how these things function. While I don't necessarily need you all to do a bunch of equations or, calculate things out for animations, it's important that you have an innate understanding of how something should move. Basically, with Newton's laws, we want to get the idea that everything requires force to start moving, and the force required to stop it moving is usually friction or gravity, but it needs some force to get it to stop moving. As well as this principle that every time we make any kind of movement, it has an opposite effect. This is one of the reasons that I mentioned, hey, before I start walking forward, I walk backwards a little bit. I rock myself backwards. It's because I'm building up an inertia to go forward. Like when we jump, technically we are putting energy into the earth that is theoretically pushing the earth itself, but in such a tiny, minuscule, completely immeasurable way. The Earth's mass is so much larger than ours that the pushback from the Earth results in us lifting off the ground. And having an innate understanding of what's happening here is essential to being a good animator. So this principle of slow in and slow out is primarily concerned with spacing. So we have a pendulum here swinging back and forth. And while the poses of the end frames and the middle frames could all be the same, what we really get the sense of slow in and slow out is the frames staggered towards the poles, the frames staggered towards the keyframes on the ends here. That tells me that the object tends to slow down as it starts counteracting gravity and starts to swing the other way, and it speeds up, or we see the frames space out into the middle. So squash and stretch is all about this transference of inertia. We know something stretches when it's moving quickly in a single direction. It squashes when it impacts or hits in the other way. And it's trying to demonstrate this overall inertia for us. We want to this like slow in, slow out is what we get to use to show how heavy something is. And this is why it's so important for our first project, the lifting the weight assignment. Lifting a weight is a pretty classic animation starting exercise just to demonstrate where center of weight, balance, and all that is. If the character lifts up the weight with no energy, no effort whatsoever, we won't get the sense that it has any physicality to it. Both of these characters make a pretty strong effort to lift it and build the inertia into it to accelerate it upward before they leave it down on the table. And we even see the way they drop it down really indicates the weight of the object. Another thing we can think about with slow in and slow out is it can tell us a lot about a character. So I like to think about Mike and Sully from Monsters, Inc. Mike is large, lumbering, and slow. His arms make up like a third of his body weight, and we see his shoulders and his torso tends to make all of the movement. And whereas, I'm sorry, Mike Sully's the one who's the large one. I always get that mixed up. People always correct me. Mike Wazowski is the little green guy there, but his limbs are so light he can jump around rapidly. His center of weight is all balanced around this ball form he takes, so he can flip and jump and move all over the place. Whereas Sully is more lumbering and slow and tends to lean in with all of his movements. These two characters move at different rates with different inertias to demonstrate to us their physical mass, which makes them more believable as characters. So here again, we see Sully. He's heavy. He's slow. He tends to have large exaggerations before he starts doing things. And, when we see him fall over there, we get a sense that he rolls all the way over because there's a lot of weight to transfer. Versus Mike is light and fast, and he snaps from pose to pose almost instantaneously, demonstrating how little weight he's really moving around, giving him the idea of this really light and kind of frail frame. We also get here's a Pacific Rim, kind of demonstrating this movie. I think does a really good job of selling weight of digital creatures and things. I see a lot of you've seen a lot of big robot movies, monster movies. They used to do these with miniatures, and they had a really hard time selling the idea that these were big and heavy. But the animators on Pacific Rim did an excellent job of getting this concept of weighty follow through. That even though the fights are fast and highly paced, you can see the inertia being built up and following through in the action. Or we get something light and fast like a fight scene from Ip Man here, where we see that the force he's generating is via the acceleration and not the mass, and so he's moving with these lightning rapid-fire punches. Now, if the robot in Pacific Rim was punching this fast, it wouldn't make much sense. And if Ip Man had that much wind-up, it wouldn't also make sense with his light, speedy kind of a frame. The Pixar animation short for the birds is another good example of this. They contrast the heavy versus light. This big bird is lumbering, he's slow, and he is awkward. Whereas the tiny birds move almost instantaneously, their poses change very quickly, and they rapidly move from one facial expression to another. So we're all thinking about a transference in inertia. This can often break those slow in and slow out kind of things. This is a Newton's cradle, and you see that the sphere, when it swings out, seems to accelerate instantaneously. It doesn't have a slow wind-up. That's because the inertia is being transferred from the other ball being clicked against the series of three balls, and it's transferring the inertia in directly. So a transference kind of breaks these rules of slow in and slow out, where we don't need an acceleration. For instance, this train careening through accelerates everything. It hits instantaneously because it's transferring inertia that it's already built into a system. Or the energy of this trap, this whip-like form, already has enough potential energy that it accelerates Russell almost instantaneously when he touches it. I like to think about this as an example of if you, if you're running really fast and you run into a wall, your acceleration stops instantly because your inertia is being transferred into that form. And similarly, if you're standing still and a large wrecking ball cartoon style hits you, you get the inertia from it transferred to you, but it had to build up that inertia at some point. So one of the important things to understand when we're looking at slow in and slow out is how does it look on the graph? How do we start reading it? We played a little bit with the graph last week, turning everything into stepped keys so we could focus purely on core poses, which is a workflow I'm going to want you to use, especially when we get into characters. But you need to start understanding as we go from poses and our poses are locked in and they look good, how do we actually get to the crafting, the curve part of it? So this is your standard graph that you'd usually see when you see a slow in and slow out. We can see on this curve on the axes, there is change over the left side, and we see running across is as time goes. We see as time goes, there's very little change, and then we're getting a lot of change over a shorter amount of time, and then less change over time. So it's slow in, it moves the fastest in the middle, and then it slows out. This is what Maya usually creates automatically whenever we start one of these. Almost any time we create a new keyframe, Maya is going to make something that looks like this. You put a keyframe here and a keyframe up in this corner, Maya is going to generate this kind of a curve because it's assuming what you want to do has inertia, has energy to it. And so in a usual situation, this is when I say when we were doing our bouncing balls, if it's something waving itself up and down, this makes sense. But if it's a ball bouncing, we want to show that inertia being transferred. So it actually would look like a curve falling straight from here and curving outward because we want to show a transference of inertia based on an impact to the ground and then redirecting the other way. Here we have a really slow in. So we see that a slow buildup and then a sudden stop right here of our acceleration. So we are slowly building up inertia and energy, and then maybe I run into something. I smack right into it, and my character stops instantly. Here we have the idea of something maybe has impacted me. Maybe I got hit by something, at this point, and my rate of change is an instantaneous curve. But then as I tumble away from it, I start to slow down. This also might be like a bowling pin hit by a bowling ball. It accelerates instantly, and then it quickly curves off, and its rate of movement starts to slow over time. This curve describes something of an anticipation. The idea that although the primary action is to slow in and slow out, we see that it dips below its original state. So maybe this is a punch being pulled back before it's being rocketed forward, or a person sort of stepping back before they lean in for something. So this is what an anticipation would look like on a curve. Versus this graph would be more like a follow through. We see again the slow in, but then it overcorrects before it comes back to a position. Maybe I'm reaching for something. Maybe I'm pointing at an object and my hand carries through where I'm finally going to leave my hand, where it's actually going to stop when I'm done moving. And this here might be something of like you accelerate into something and then you kind of have a wobble or a whip kind of like motion. Maybe like a something that like I think a good example is an arrow hitting into a tree, and it does that thrumming where it sort of wobbles back and forth as it hits something. But we want to start understanding as we're reading these graphs and becoming comfortable with, I can see what's happening is a back and forth between the amplitude between these peaks starts to become tighter, therefore it's happening in less time, and the height of them, like the frequency, that's the one in between, starts to get narrower, so it starts happening quicker, and the amplitude, the distance between the peaks and the valleys, starts to get narrower, meaning it's making less change over time. The graph editor I find when people are first starting out in animation is one of the hardest things for them to sort of wrap their brains around initially, but as you start getting more comfortable with it, you're going to start reading it just like you read anything else. It's like the Matrix. You'll start reading it, and you'll just start not seeing the numbers, but seeing what it represents and what it means. This is a great quote that I want you to think about. Why when we're creating cartoons, when we're creating like things that are supposed to be emotional performances that are supposed to be exaggerated, am I talking so much about physics, inertia, and energy? And one of the things that Walt Disney's animators really discovered is that there's this hand-in-hand nature of realism and exaggeration. And he felt that their work, they needed to do so much study. In fact, Disney animators spent a ton of time studying life models videos of people in motion, animating objects just in motion physically so they could start to understand the principles of motion underlying everything, and then they could exaggerate it. And Walt really felt that all of his animators needed an essential foundation in the realism of movement before they could truly start to exaggerate it in interesting ways. So while we're not here in person, and I'd love for us to do all these exercises in class, I can't really because we're not all here. But something I want you to do is there's a couple of, like, take an animation from a film you like and just maybe take a draw over pen tool. Personally, I like the tool Epic Pen, which is free and it's really easy to use, especially if you have like a Wacom tablet. Or you could just take a regular dry erase marker. If you have like one of those glossy screens, you can always put something clear over it if you're worried. But I actually draw over my screen quite a bit. I usually don't do it though on the more matte, like the glossy screens work well for that, but the matte ones not so much. And lets me just sort of draw over and think about the lines, the curves, and thinking the goal here is to pick a single spot, like I said, like look at a nose or an eye or something like that. And you just hit a little dot and you can start to see frame by frame where things are staged together, where things are moving quickly and where they're moving slowly. Dissecting and like pulling apart something that's good that you know works well, like Pixar animation, is a great way of learning some of their secrets and tricks and getting a better sense of what are they doing to make this look satisfying and believable, and how can I bring those lessons into my own animations. The next thing I want to talk about here is arcs. Everything we do and see moves in some kind of an arcing path. This here is actually a model of our solar system representing Earth in blue and Mars in red. And we think of ourselves as this elliptical pattern. It's simplified, of course, because we have ellipses, not circles, around the sun. But we think of ourselves as moving very linearly. But not only are we on a spinning Earth that is looping around the sun itself is looping its own path through our galaxy. It's fascinating how much inertia and motion we can't feel because we are under the grasp and inside of it. And our Milky Way galaxy itself is also spinning and moving inside of the known universe. These are just things we've observed from astronomy. And so everything has this foundation of moving on these circular, rotational, or arcing paths. This was, in fact, one of the earliest discoveries of astronomy, when early astronomers were trying to chart out paths of planetary bodies linearly. And it was Galileo and Copernicus, I think Copernicus was the first to really think of them as orbiting bodies. Galileo did a lot of the stuff to figure out like the actual pattern of those bodies, and Newton was the one who solved the conical ellipsis problem that led to calculus to help us predict the actual movement of planetary bodies. Because when people started charting out these things moving linearly, they found the same thing we find in animation. If you actually go out and you study, for instance, the position of the moon at night, and you just start charting it, you'll find that it doesn't make an even spacing between each thing. It starts staggering up and making more changes closer together, and then it seems to move rapidly, and then slowly, and then rapidly. And this was something that baffled astronomers for years. They thought the planetary bodies had some will, that they were suddenly moving, and then they would move slowly, until it was later discovered that they were moving in these large elliptical patterns. So what is an arc? We use the term arch or arc or anything for, essentially we tend to calculate it in mathematics. If you could think about this arch here as these 2 points and then the keystone up there and the section of the fully circular rotational section between them. We use curves a lot in graphics. We use them for calculating NURBS. We use them to make Bezier curves for vector art. But arcs are difficult for humans to do and easy for computers to create, which is one of the reasons our arcs are really great to use Maya to create for us. But arcs are important for animation because motion is more natural in an arc. We can see in the left side of the animation, it's moving forward and back, but it's moving linearly. whereas the right animation is making an arcing circular path with it, which feels more natural. I see this a lot when I have students in 247 start to do their arm swinging in their walking tutorial, and they make their arms slide back and forth linearly using the IK controls, and it looks really unnatural because in fact almost all parts of our body swing at almost all times. So we see that a natural motion is one that makes an arcing path versus a straight line feels actually kind of awkward. There's an old riddle that say what's the shortest distance between two lines, and it's always, well, the shortest distance is a straight line. But in actuality, especially when you look at like the surface of the Earth, a shortest distance is a curved line. We have to curve over the Earth. But more so than that, we tend to make movements, we tend to walk in curves because it conserves energy. If you looked at the distance the hand travels in the left example, it's actually moving a little bit more than the hand on the right. And so you'd think that that would mean it's expending more energy. But in this case, the hand on the left making a circular arc is using a lot less energy because it's having to make fewer corrections to redirect itself. It's sort of just flowing and transferring that inertia slowly and gradually to turn itself around. Versus the example on the right, moving linearly, is requiring the hand to make a lot more effort and energy to stop and redirect itself. If you want a good example of this, try this yourself. See if you can make your hand move like it is on the right side, and then move your hand like it is on the left, and see which one feels more natural and which one feels like it's taking more energy. Maybe if you do a little people watching out there, I know no one's really walking around today because it's freezing, but take a look at how people actually walk towards objects. They don't stop and rotate towards it and then orient themselves straight. They take long, sloping, arcing paths walking towards things. So we can think about it like, a fill in the numbers or a fill in the blanks kind of thing. About where between frames 1, 3, 5, and 7 we want frames 2, 4, 6, and 8. And so while we find that something like A or B seems the most logical, C is the one that we actually tend to do. We kind of use a little pinching. We kind of go towards the poles. And C is actually also how Maya calculates subdivisions, like when you take a cube and you smooth it to make a sphere. It's essentially working the way C does, where it's drawing lines between like 1 and 3 and using that to determine where 2 should go. B is like a pretty extreme example of curving or arcing through something, but you're not generally going to find it moving that circular. And A is going to be just really completely wrong for your animation because it's going to feel artificial and it's going to feel very robotic. So mechanical objects, this is a little clip from back in Sesame Street when I was a kid, and they made a whole little animation of just different mechanical objects that I always found fascinating. But what we'll see about mechanical objects is they tend to have, especially, get into it a little bit with the mechanical assembly machines. You see that they tend to move very linearly and very strictly back and forth. There's still rotations happening on the machines, but this is why, like, the Dance the Robot works, is because you're moving linearly and not rotationally and awkward starting and stopping, which is exactly how we expect robots to move, because they're programmed by people who are thinking about moving, but they're actually expending more energy. This is the same thing you don't want to do with your animations. Logically, it makes more sense for everything to move super linearly and restricted, but for your actual animations to make something look human and lifelike, it needs to move in smooth, arcing paths where the inertia is transferred as opposed to started and stopping. So here's an example, again, of organic motion, and I want you to look at like the arcs the head makes, look at the arms swinging, and even the feet don't really move linearly. They're swinging back and forth as they get into position. Everything here could be plotted or tracked at some sort of an arcing path. If you look back at him walking from the front view, you can see arcs happening as he sways left to right and back and forth. Nothing on this body is happening or could be drawn as a linear line. Nothing would make sense that way. Compare that to something like the walking of Asimo, And so again, we see these robots move very linearly, very straightforward. The hips not really rising or sinking for the motion because he's walking with his legs, not with his body. I mean, there are examples of things that are stationary. Chickens are kind of fascinating this way, in which, because they're birds, they're very good at keeping their heads completely still, almost like a chicken gimbal here. So we are capable of moving linearly and moving straight. It just requires energy and requires force on our end. So this can be seen, this kind of arcing path can be seen everywhere in the motion of objects. A good example here, this is a little video describing Stephen Curry's like 3-point shot. And one of the things that makes him effective at this is they actually talk about not only how quick he gets it off, but the arc he shoots it at is unique compared to most basketball players. So his angle is higher, therefore he has a stronger arc. And what that means is it's coming at the net higher from a more severe angle compared to someone who's coming at a lower angle. And especially what that also means is that he actually has more hoop to hit, because he's not hitting the hoop at an oblique angle, he's hitting it straight on, meaning he has a better chance of actually hitting a 3-point shot just by changing the arc or curvature of his 3-pointer. Arcs are completely natural. I want everyone to try this out right now. Is take a sheet of paper on your desk, and I want you to draw a straight line from like one corner to the other of the sheet of paper, completely straight, in one single motion. Now try to do the same thing, tracing from one end to the other, but instead draw it as an arc, a curving path. And you'll see almost instantly which one feels more satisfying on your arm, which one draws a more natural arc through the page, which one's easier for you to do. Especially if you engage your hips and your shoulder and your elbow. Whenever I'm drawing, I'm actually drawing from my shoulder, never from my wrist, because your wrist gets tiny little hatch marks. Drawing from your wrist is like, that stuff is good for handwriting, but for drawing I want nice big lines, and so I use my shoulder a lot. And if I'm drawing up on a whiteboard, I'll use my entire body to help me produce nice, smooth, clean arcs. When we're thinking about our animations, we want to make sure we take these arcs into account. Here's a little example one animator did of a little combat animation, and drew the initial poses and then just drew little arrows indicating where different arcs were going to be happening, so that this animator could better understand the motions that were being transferred through and where the energy was going to go next. It's always a great idea to sketch things out, and if you're having a hard time thinking about what to do, get up, move around, pay attention to your own movements, sit down, make a little stick figure, and jot out those movements and think about how that energy is being transferred, what direction it's going in, and how severe that arc is. So we see again this, like, we've gone back to the arcing path, this idea of curves, and we're combining that now with slow in and slow out. And we say that not only do things accelerate slowly, and they tend to move in arcing paths. So combined together, we're starting to get more physical movement, and we can start to get things like, start working with our walking. So we looked last week at our pose-to-pose animation, and how we could break down an action into a series of individual poses. So here's a classic walk cycle: contact to contact to contact, high points in the middle, and then our recoil passing points all happening here. So I guess the passing point is the middle technically on this one. But if I chart out, say, the position of this head or the feet, you can see everything's a series of looping actions. If I was in person, an example I like to do is I go in front of a whiteboard and I just walk alongside of it with a marker next to my head, and it produces a completely even wave like this, an even sine wave, because my head is bopping up and down. I'm actually teaching, again, the 247 students how to do walk cycles right now, and the thing I always teach them is move the hips up and down first. Have them just bob up and down. And it doesn't feel natural, but if we see here, it's actually the most important action that's driving all of this walking. So as you're thinking about your poses and you're thinking about your movements, think about what is the hip doing? What arcing path is the center of gravity going through? And how is that going to transfer weight through the whole body? Arcs also produce for us lines of action. They make things more interesting, better to look at. So the examples on the left, this is from a classic like 1930s animation book. We see these curves are awkward versus the curves and arcs here on the right side of one cat punching another cat tells the story. This line of action says this punch starts in the foot, pushes all the way through into the fist. It feels like it has energy and impact. The other cat is being curved at the point of impact, really telling us that that cat is getting walloped here. And we see the same thing down in the bottom row. This feels like an awkward pose to swing our little club, versus here not only denotes that we're building a lot of energy into it, the direction of the curve gives us an indication of where he's going to swing the club. And then we get the complete opposite curve on the other side when the club is swung to demonstrate that that curve is flipping the other way. The contrast gives us the concept of energy happening here, and it can make a weak animation feel really, really strong, or vice versa. Arcs are action. So like in the superhero fight scene, look at how many arcing paths tell the story of energy, of impact, and of movement. Less linear, more arcing. It makes things more interesting and easier to follow. That's the difference between a jab and a haymaker. So the second exercise you should check out at home is take that animation, whatever animation you examined the last time. In this case, like what I was giving everyone is a Buzz and Woody animation. You can find literally anything you want. And I just want you to look at how do the hands move differently than the head. What you're going to discover as you go through it is how much more the hands move, and the times at which the hands move ahead of the head and when they move behind tell a lot about the story or the expression of what's happening. So the next thing I want to talk about here is this concept of what's called solid drawing. A lot of people don't think of this as being relevant to 3D animation because we're not drawing in 3D animation. The model is already made for us, or it's in a 3D programming thing, so they don't think it's relevant. But I want to talk about where solid drawing really comes into play, especially for 3D animators. So when we're trying to create a 2D character, solid drawing is really essential to creating the illusion of 3D. So Homer Simpson from The Simpsons is almost never shown directly straight forward like the left. He's almost always shown in a 3/4 view on the right. Not only is that good stage direction, but it helps us have a better sense of the geometry of the character. There's a lot of thought and time and paid attention to the simple shapes that make up Homer Simpson. And we also have this idea of, two-dimensional drawings creating the illusion of form. This is an example of a blueprint where an engineer can draft up this blueprint and someone can fabricate this because they can understand the three-dimensional form based on these two-dimensional lines. And so when we think of solid drawing, that's usually what we're concepting. Here's an example, too, of a character sheet from Aladdin. And even though they weren't using 3D modeling from this, we see them drawing lines, topological lines over the characters, much in the same way that we might if we were trying to make a 3D model of the character. Because they didn't want the genie to feel like flat or like some wispy smoke. They wanted him to feel like he had a dimensionality into him. And so as they squashed and stretched the face, they wanted a solidity to it. And so this is where we get this idea, is this conservation of mass, this movement of form, and showing the audience that it is physical and real and not flat or artificial. We kind of do have this, though, in 3D animation. What we want to do is we don't want something that's stiff and poses that are awkward, which can make it feel flat and artificial. So like this runway walk here, animated, it feels awkward, it feels stiff and flat, versus we look at a real human being and there's an actual plasticity to it. So plastic means that there is bounce, there is movement, there's swing, that these are physical forms that are actually capable of bending and flexing. I like to think about solid drawing, and I want you to take this as an opportunity to think about the physics nature of your poses. For instance, you want to avoid twins. Twinning your animation or your poses on the left and right side often feels awkward and artificial. This is also something I see a lot of starting animators do with their animations, is they'll make the same thing happen on the left and right side, where contrast is much more interesting. We see not only are the hands posed on the left and right side, the eyebrows are the same on the left and right side, the eyes are the same on the left and right side, and the head and everything else is completely straight. Avoid straight ahead motion. Avoid moving things on simply one axis. Avoid having your head straight up and down, your body straight up and down. Remember, we're lazy, we slouch, we lean, we put our elbows on tables. Use all of that to make your characters more interesting and more expressive. Every single frame is a drawing. We should be able to, like we talked about last week, we should be able to pause any frame of your animation and see an interesting composition that tells us a story. This is another 4 examples from 4 different movies, just paused at random elements, and they all have good staging and framing and composition, but what's really important is they have really good poses. So, a classic drawing here of Mickey where they demonstrate you don't want to have Mickey's feet flat together, his head tilted to the side, his hands on exactly the right side and left side of each other, because it feels flat and it feels wooden. They made a real effort to make Mickey feel like he's leaning, he has energy, his head is tilting, his hands are posed in contrasting ways, which draws attention to his focus towards his object he's looking at. This is more interesting to look at and more engaging. Posing is actually a real art. In fact, a lot of people think about modeling. I had this little video I like to show where this model is walking through all of the different types of poses she does. And a lot of people think modeling is just like looking pretty and standing around. But a lot of people can't do it. It's like ballet in the way that they have to use their bodies to communicate something. And their pose and the line they draw is really important. So she's actually in this little video going through what she sees as the essential ways she thinks about orienting and rotating her hips, her shoulder, her hands, because she's trying to draw a pose that is appealing and eye-catching. And if she was standing awkwardly or positioning her hips or her shoulders or her hands in a way that didn't draw attention, she wouldn't be doing her job. When I was making characters for this advertising campaign we did for a summer camp program, we talked a lot about how characters needed to be readable. One of the things that was essential for this project is the characters need to stand on their own and they need to be composed together. So we needed them to have an expression to them, poses that indicated slightly different personalities, different attitudes, different types, different body types, different, types of science and technology, but we also had something that needed to read together as an entire poster so they wouldn't overlap with each other. Because we want our audience to see what we're looking at. All of our factors need to be readable, and this is where our poses come in. One of the most common comments that people get when they're trying to start on animation and they're showing to other people is that your poses need to be stronger. This example on the left of a guy crying or upset, we see maybe we can get the sense of his emotional expression, but there's a lot of things missing that make the right-hand side much, much stronger. For instance, by placing the elbows on the knees, we get the idea of the character really leaning into the expression. It compresses him more, it makes him feel more down, and it makes him feel more flexible. We also see the facial expression from being straight ahead. His head is now turned. His mouth is slightly open, which gives us a more exasperated, breathing expression. This looks more like someone in distress. And then really essential, the posing on the fingers. Whereas we have those kind of mitt-like animated fingers on the left side. On the right side, we see the hands posed in 2 different ways, demonstrating anguish or a pain in this character. So you can see here, spine is curved, fingers rotated, and elbows are touching on the point. Here is like a talk to the hand, and while they're both doing it, the one on the left is much less interesting versus the one on the right. We have this contrapposto, where we have a curve working this way versus a straight line, and he's actually looking to the other side. So this makes not only is the hand actually on the hip here, the arm is locked and straight, putting more emphasis on the hand, putting it further out into perspective, and showing it to us, the viewer, gives us the kind of sassy attitude that we really want to sell here. So, like, here are two pictures that I found shortly, right at the same time. And it's amazing to me how remarkably similar they are, but it's also amazing to me how different they are. Both of them demonstrate a similar level of technical skill when it comes to rendering and figure drawing. Both of them are about the exact same thing: an angel with a sword flying down from one side of the screen to attack a demon on the lower left side of the screen. I mean, the similarities are pretty amazing, but one of these, the one on the left, is much, much stronger than the one on the right, and it's all down to poses. If you take a look at the one on the right, you can see that even in the initial frame, when the character was first being plotted out, this artist was already struggling with the poses and creating an interesting form and creating something that was nice and readable. And so here it didn't matter all of the rendering in the world, and this is really, really well rendered on here. I mean, the actual artistry done to put attention to detail and the lighting, the surfaces, the rendering, I don't want to knock this person. They did a great job, but it's a shame because it's in the service of poses that just don't sell the action very well. We see not a lot of attention paid to curves and motion. We don't really get a sense of the direction that this guy is moving or what this character is about to do. And in fact, there's a lot of character details on this demon we miss, like this little bony protrusion on the back, because it lines up with other bony protrusions on the back, and we don't get a sense of a threat, and we can't really see his face because he's looking away from us. We have all this empty, unused space up here, and there's a lot of awkward holes. And this guy doesn't look like he's ready to swing his sword. It's too in front of him. It doesn't look like we're ready for an actual action beat. Versus here, the sword is off to the side, the hand is forward, contrasting the two actions. The character is sweeping down. It feels like she's really swooping in and ready for a sizable attack. And the demon, instead of being so full body, we don't really need the tail and the feet and everything here. We focused on just the exciting or interesting parts so we can see the face and its demonic presence. And as it's preparing to contrast against, and we create this nice dichotomy, and they even put this little claw sort of weapon element in here, filling up the empty gap we had here, and a couple of interesting elements of detail in the background, so we just didn't have empty space. Again, it's the layout and it's the poses that make this painting suffer and doesn't really read as well as the other one. I think when it comes to pose, maybe no artist has a better sense of raw energy as Frank Frazetta. Frank Frazetta was a great fantasy artist. He actually started going to a fine art school at 8 years old, and he was a comic illustrator at 15. He was an absolute prodigy, especially when it came to characters. He's really known for this style of art that became famous for like van paintings and fantasy art, but his art style inspired Zelda, He-Man, pretty much all of Dungeons & Dragons. Everything fantasy-oriented you think of was a creation of Frank Frazetta. And he had a real interest in energy in human bodies, similar to like a Michelangelo. And he would create these compositions that felt like these freeze-frame moments of time and all just this raw energy and power going into it. But I want to break down a frame of his and how he actually uses all of these principles to create great poses. So here's a quick sketch of his, just like a little ink drawing, and it's fascinating how many things he does well here. So we see someone ready to fire an arrow, maybe an ambush of some kind, but let's start looking at all the lines that are putting this together. So for one, it's solid. We can tell the way that it's fit together. It feels like tubes and not flat, noodly things. Okay, so solid is step one. That's good. But all the lines are moving towards the same direction, something I think is really cool. So we see the positioning of the arrow right next to the head like this means that if you look at the leg, if you, for whatever reason, we're looking at this leg, it would draw your eye up to the face. If you're over here, we see the lines draw up to the face. If we're looking at this jutting out arrow quiver, we're going to move up to the arm, which directs our eye to the face. And if we look at the bow, We're gonna draw. Our eyes are gonna follow our way up the bow, go down the little string, and it's gonna take us to the face. And the face is looking straight ahead. And it's almost like we're seeing the figure all together, all the lines converging to the eyes, and the eyes staring forward, ready to release the arrow. This is how a still image can look almost like it's animated, because we're telling the story through the way our eyes are being drawn through the pose. Everything is clear. We have this strong line of action here that draws our attention to the face draws our attention to the arrow, and there's a nice, clean, straight line. We see the elbow posed, the hand, the arrow, the forward hand, all of it drawn straight through. If this elbow was sinking down here, it wouldn't feel nearly as impactful, but drawing the longer that we can make this line, the more energy we give the arrow's release. And not only that, the silhouette is really readable. If we give you this as a silhouette, you can still tell me exactly what I'm looking at, because he hasn't chosen to put the bow, in front of the character. He hasn't put a bunch of rocks up over here, kind of obstructing the silhouette. He's done a really good job of breaking out exactly where the character is. So, coming back again to compare, and again to keep, poking fun at whoever made this. Again, the rendering is really good. But we see there's a lack of curves to the action. There's a lack of sense of energy to the direction these things are moving. So this is the last little exercise I want you to do in thinking about this, is take, I had a little printouts of images that I want you to do, but take a look at a sports page or a comic book, and I want you to just even trace with your hand or with a pen tool or something like that, the curves through it. Find the curves in it, because the more you can discover what curves interesting actions are making, the better chance you'll be able to replicate it yourself. So that's our lecture for today. I want to really quickly bring up our actual lab. If we could take a look at that. We we're talking about splining here today. And I know some of you have done this already, but I just want to talk a little bit about what this is and what we're doing. I've started you off with the stepped key animation already. So you have the animation itself, a little sketch indicating what I want you to do. The goal here is just to think about the splining, the transition between things, and how we can use these curves and change them over. Now, last week I showed you how we can set the in and out tangents to stepped, and so that every new arc you create will be in stepped keys. This is, you have to change this back. Now, changing this won't change any keys you already have. This just means each new key gets calculated this way. What you have to do to any keys that are already created is select them and then press this, ideally these clamped curves. You can also do auto key, but I find that tends to auto correct stuff. I like clamped curves because it won't let the motion go beyond. I want you to control that yourself. I don't want Maya doing that automatically. And really going through, and I try to take you through how you can get rid of keys you don't need, how you can focus on just a couple bits. The goal here is not to create any extra frames, but be able to take the few frames I've given you and create a nice little dance animation motion and just play with the curves to get something that feels like you got the slow in and the slow out, that you're making arcing paths, and that you're striking good poses at each frame of your animation. So when you're done with that, post it just in our weekly animation section, and I'll take a look and make sure everybody gets checked off. Thanks everyone for dropping in with me. Sorry about the weather, but we'll be back to next week, next Wednesday, right back into our animation stuff, and we'll be working on our last section of Principles Animation, talking about the project, and getting ready to start getting into some serious character animation work. Thanks everybody, stay warm.